All right, so last week we talked about different functions. Remember, we reviewed what an x squared function is. You guys said you heard of a parabola, quadratic. We talked about the absolute value function, how that's a v. We're going to throw what x cubed functions look like in today because we're going to be talking about what we call parent functions. These baseline functions that don't have any changes to them. What do they look like? Also, with this lesson, you'll see that there is an image in here called parent functions. That's something you might have handy. I used to have it taped to the front of my desk so that I could just always quickly recall, oh, this is an x cube function. What does that look like, right? Some of the ones you use more often, you will start to remember, but some of the more obscure ones, sometimes you forget. So we're going to talk about transformations. So this isn't a review for us, but we're going to talk about what transformations are. Transformations are when you change a graph. So when you change a parent function. So when you change, let's just graph x squared here. You guys know hopefully what it looks like, right? So if I have f of x equals x squared, if I plug in -2, I'm going to get 4, right? Because -2 squared is 4. If I plug in -1, I'm going to get 1. If I plug in 0, I'm going to get 0. If I plug in 1, I'm still going to get 1. And if I plug in 2, I'm going to get 4. So that's that parabola shape we're talking about, right? 0, 0. Then at my 1s, it's 1. And then at 2, it goes up to 1, 2, 3. 1, 2, 3, 4. And then over here, the 2, it's also 4. So that's kind of our general parabola shape, right? So let's do this one too. X cubed. If I take -2 and cube it, I end up with -8. Okay, if I take -1 and cube it, I end up with -1. 0 cubed is 0, 1 cubed is 1, 2 cubed is +8. So you can kind of see how it's going to reflect. So we still have that point 0, 0. -1 is -1. -2 is -8. So let me count that. 1, 2, 3, 4, 5, 6, 7, 8. I think it's here. Okay. And then it's kind of flipping up here this way. 2, 3, 4, 5, 6, 7, 8. So somewhere up here. So a cubic function, an x cubed function, looks like that. Okay. So the zeros here, where does it cross the x-axis? At 0, 0. Same over here. Right, those two both cross at 0, 0. And now let's do absolute value of x. So let's just remember that. If I take the absolute value of -2, I have 2. Absolute value of -1, 1. Absolute value of 0, 0. Absolute value of 1, 1, 2. So that's how we get that V shape, right? It's basically a line following those up like this. Where are the zeros? At 0, 0. Okay, so these are just 3 parent functions we're going to work with today. And we're going to be performing transformations on them. So transformations are changing these parent functions. So there's 4 different, actually we're not going to talk about rotation. So there's 3 different types we're going to talk about today. One is translation. Translation is just when you're shifting the function, and it can be up or down, or you can also shift it left or right. So basically taking this whole thing and moving it up, or taking this whole thing as it is and scooting it over to the right, that's a translation. A reflection is kind of like your mirror, right? When you look in a mirror, it's your reflection. It's not how you actually look, it's reversed. So a reflection is when you flip the function over the x or y axis. So it can be either. It can be a reflection over the x-axis or a reflection over the y-axis. So taking this thing and flipping it down would be a reflection over the x-axis, right? Okay, a dilation. This is a stretch or compression. And I'm going to put in parentheses here that it can be horizontal or vertical. So that basically means I'm going to take this thing and stretch it up to make it tall and skinny. That would be a vertical stretch. Or I'm going to take this thing and squash it down so it's wide and flat. That would be a vertical compression. But those are just the vocab words you need to know, and I'm going to show you how those work. Okay? So here are our regular parent functions, and now we're going to perform some transformations on them. Let's go to the next page. Pause if you need to write this down in your notebook. Okay. So I started some of this here with the parent function x squared. So we know x squared looks like this. So all I did was copy that graph from the front. It's got the vertex at 0, 0, and it keeps going on and going up, right? So what happens if I have x squared plus 3? So let's work on that. And I started my table here. Let me zoom in so you can focus on that one. X squared plus 3. So if I plug in -1, I have -1 squared, well that's 1, plus 3 is 4. This one, what if I plug in 0? 0 squared plus 3 is 3. And 1 squared plus 3 is 4. So all I did was pick 3 points so I could graph this. So let's check. I have 0, 3 is a point, -1, 4 is a point, and 1, 4 is a point, right? So you can see it's a sketch. So those are those 3 points that I plugged in. That's where they would be. So what happened between this graph and the original parent function? What did this plus 3 do to it? It's plus 3. Hopefully you can see what the plus 3 did to it. The plus 3 moved the function up by 3. So the transformation here would be a vertical translation, squeeze it in here, translation up by 3. So this adding plus 3 to the entire function moves the whole function up 3. We basically took this thing and went boop, 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 3 spots up. Okay, so now look at this one. This one looks pretty similar to that one. There's still a plus 3, but now the plus 3 is inside the parentheses. It's x plus 3, then the whole thing squared. Here the plus 3 was outside the parentheses. So what does this plus 3 do? So I graphed it already, but I'm going to show you the points. Let's plug it in. -1 plus 3 is 2, and 2 squared is 4. 0 plus 3 is 3. 3 squared is 9. Or did I do that wrong? -1 plus 3 is 2. 2 squared is 4. 0 plus 3 is 3. 3 squared is 9. And 1 plus 3 is 4. And 4 squared is 16. So at 0, let's check these. Let's start with -1. At -1, I'm at 4. Yep. At 0, I'm at 9. Yeah, somewhere up here. And at 1, I'm at 16, somewhere off the graph. I graphed these for time, but really you could make this table on your own and then graph it. And I can also check if I plug in -3, -3 plus 3, that's 0. 0 squared is 0. That's where the new vertex is. So how is this function different from the parent function? Well, before the vertex used to be at 0, 0. Now the vertex is at -3, 0. So all that plus 3 did was shift it 3 spaces, but 3 spaces to the left. So here the translation is a horizontal translation, right? Because it shifted. I'm going to abbreviate it like that. And it's left by 3. So one thing you want to note here is that for the vertical translation, if it's a positive number, it moves it up. And if it's a negative number, it moves it down. For a horizontal translation, so when the number being added is inside the parentheses just on the x, if it's a plus 3, it actually moves it over to the left. If this was a -3, it would move it over to the right. So the horizontal shifts are actually the opposite of the signs, or the vertical match. But we're going to take some notes on that in a second. Okay, now let's check this. Let's check if that's true. So plus 3 moved it up 3. Does -3 move it down 3? Let's zoom in. Yeah, it does, right? Because if I plug in -1 squared, that's 1. 1 minus 3 is -2. 0 squared is 0. 0 minus 3 is -3. 1 squared minus 3 is -2, which is where these numbers are. So this is the opposite of this shift here. When I take away 3 from the entire function, it's still a vertical translation, but now it's down by 3. Same here, right? X minus 3 squared. the opposite of this here, when I perform those operations, so -1 minus 3 ends up becoming -4, and -4 squared is 16. 0 minus 3 is -3. -3 squared is 9. 1 minus 3 is -2. And -2 squared is 4. And all of those are here. These points, I already graphed it for you. And you can see if I plug in 3, 3 minus 3 is 0. 0 squared is 0. That's how I get the vertex. So this is showing the inverse of that, right? When you take away 3 from just the x, the operation's happening inside the parentheses. So horizontal translation. But this time it's to the right by 3. So hopefully you can see how these two relate. They're both vertical translations, just the opposite. And then you can see how these two relate. They're horizontal translations, just the opposite. So what I'm going to do before we go over the rest is we're going to take some notes here. So it says, what kind of transformation occurs if we add or subtract a constant to the parent function? So when that adding or subtracting is to the entire function outside of the parentheses. So that transformation is a vertical translation, right? Moves it up or down. If we add the constant, the function will shift up. If we subtract the constant, the function will shift down. So if you need to pause that and write that down, go ahead. And then the other thing we talked about was if we're taking the constant and adding it inside of the parentheses, so just adding it to the x. So here it's x plus 3, the whole thing squared. So if that's happening inside the parentheses, then it's a horizontal translation. Okay? Now here's where it's the opposite. If you're adding the constant to the variable, so if you're plusing 3, you're actually shifting it to the left. And if you're subtracting the constant, you're actually shifting it to the right. Why is that confusing? Because it's the opposite of what we learned about vertical translations, right? It's the opposite of, it's also opposite of our intuition. So the really important thing that you need to remember is that translations occur when you're adding or subtracting a constant. So all of these had a plus or a minus, okay? So this stuff is going to be in the next video. We're going to talk about these last two, reflections and dilations. So try to work on the translations first, see if that makes sense with you, and you can try these problems in the practice. You'll see them without the solutions there. And then you can come back and watch the other video if you'd rather do that. Or you could watch all the videos together and do the practice at the end. Okay, dilation's coming next.